In this month's update, we have a number of necessary but probably not terribly exciting things to share. These include installing the power bus, track feeders, switch machine wiring, and finally the fascia at the front of the layout. Nevertheless, I will try to sprinkle in a few interesting tidbits, humorous or otherwise, and I think I'm going to try and squeeze in a surprise at the end. Stay tuned. We'll start off with our usual side-by-side comparison. You will notice that the layout is quite messy at the moment, but the obvious changes from the last episode is the addition of the fascia around the front and the start of the backdrop, one section of it at least. The rest of the backdrop is lying on top of the layout, so you can't see the track underneath. With the completion of the track extensions through the wall underneath or onto the footprint of the cold storage warehouse in the original part of the layout, there was a need to revise the internal support structure of the cold storage warehouse because the supports were conflicting with where the tracks now had to be. So I took the opportunity to turn the support system upside down and have the supports attached to the layout rather than the inside of the building. And at the same time added 3 times as many supports to make it much more firm. At the same time, I added some foam bumper posts to make sure that no damage would be done by errant cars rolling off the edge of the tracks into the inside wall of the buildings. And here you see the building reinstalled. Hopefully won't have to move it for some time to come. That will likely be when I get around to figuring out how to camouflage the opening in the wall. But as you can see, it's not easily visible during normal operations. So it's not terribly high on the priority list. You may recall from a couple of videos back when we were installing the Tortoise switch machines, the throw rod extended from the switch machine below through the track above, and the excess wire needed to be clipped. Normally this isn't a big deal, but as you recall, I used a thicker gauge of wire to create more force against the points when throwing. And clipping those off requires exerting a fair amount of pressure with the snipping pliers to break the wire. Normally I'm able to do that with one hand holding the wire and the other hand holding the pliers, but in this case the clipped wire got away from me. For the longest while I didn't know where it went. I wasn't too concerned. I figured I'd find it eventually. But look where it turned out to be. Just a reminder to always wear your safety glasses when clipping wires. This could have done some real damage. Here's an overview of the last track feeders that I had soldered in place. Holes are drilled and these wires will be pulled down below the sub roadbed and connected into the bus wire system. This will conveniently cross through the wall to connect below to the existing 12-gauge bus wire system on the original layout. On the original layout, I used many of these suitcase connectors to connect the track feeder wires to the 12-gauge bus that ran around the length of the layout. Although I haven't had any issues with them, I always felt that they were a little bit undersized for 12-gauge wire, and at the time I think I was using stranded 12-gauge wire, and I always thought that these were somehow damaging the wire as they were being forced through it. You can see the opening is quite narrow. So anyway, I went looking for some more of these or something instead of these because I only had a handful left. Technology has changed quite a bit in the last 20 odd years. Lots to pick from now, and I think I found something better. Not only do these come in numerous different configurations, in other words, the number of wires that could be connected in at once, 2, 3, 4, or 5 connectors, they also are designed for exactly the wire gauge that I'm using. 12 gauge on the bus and 20 gauge on the feeder wires. They're also rather inexpensive, so I got a bucket of 100. I chose the 4-pin version because it allows you to daisy chain your feeder bus to connect to several track feeders at the same time. Here are a couple examples where I not only connected to local track feeders, but also created a junction between two different bus wires. This reduces the overall number of connectors you need to use. Here you can see where I've come through the wall to connect with the end of the existing bus wire on the old part of the layout. You can see that's the black wire. I've changed over to red wire for the hot because I couldn't get black wire. But that's fine, the white is still white. But you can see that I've also pulled two local track feeder connections to each of them. So you need a lot fewer connections to connect all the feeders to the bus. And of course I ran a separate parallel bus line for the staging tracks and the return loop as they have to be controlled separately. I will have the ability to turn them off and reverse polarity completely separate from the main line power bus. As I was completing the wiring of the bus, I was short by a couple of meters, and I didn't feel like running back to Home Depot to buy a small amount. I did, however, have some standard house wire, which is 14 gauge, and I thought I could use that for secondary bus lines that connect into the major 12 gauge bus through a junction. So I removed the casing to separate the black and white wires, and of course in the middle is the copper grounding wire, and so I have quite a bit of it, and I'm scratching my head wondering there must be some use for this at some point. If anyone has any ideas of how this can be used for something, please let me know. As you may have seen in previous videos, the track plan shows where the backdrop is, and it runs along this line here, curves, and then runs along this area here. This area is about 8 feet long, and this area is about 3 feet long, and they're connected by what I thought was a reasonable radius. It's 10-inch radius, and I've had 12-inch radius masonite on other sections of the old layout used for the fascia, and I didn't think it would be too much of a problem, but I didn't account for how much stiffer the board gets when it's taller. In this area here, the backdrop is about, I think I cut it to 30 inches height, because I wanted to make sure when I was looking at the backdrop, I didn't see over it. So unfortunately, you'll see in the next slide, it didn't work out very well, and I'm going to have to come up with another way to make this curved section of the backdrop. I just didn't want to have this end at a sharp point, because it's much more difficult to disguise points rather than smooth curved backdrop. So here's what it looked like. Well, I took it in stride and figured there's always a solution. I suppose I could have soaked it a little bit in water to soften it, but I assumed that that would also make it puff out and it would no longer have a smooth surface. So I've got other ideas. For starters, I trimmed the shorter of the two broken sections, and that fit quite nicely in the first section of the backdrop. So that one will go in there nicely. And I've got another full-length 8-foot sheet that will easily fit the other long straight section. So the only other remaining question is, how do I make this 10-inch radius section of the backdrop? If I'm not going to use this masonite, this stiff masonite, what other malleable surface can I use? A quick trip to Home Depot revealed a couple of possibilities, including aluminum sheeting that's normally used for heating ductwork. There's some that's already curved for piping, but the radius is a bit too tight. There's aluminum flashing that's used in roofing. I know some people have used that for their entire backdrop, but I only have a very, very small section, so it's kind of a waste to buy a whole roll for just that. There's heavy-duty cardboard, but that's a bit of a waste for a roll that size. It's also not smooth enough. But sometimes the solution is right in your face, and it's the cheapest and simplest one. For $1 and change at Staples, a single sheet of Bristol board will probably do. I'm going to give that a try, but I won't have the results to share with you till next video probably. I forgot to take the before photo before I did this work, so I've grabbed this shot from an earlier video. It shows how the 5-track helix staging yard is rather exposed from above and from all sides really to something that may drop on it or being bumped while I'm behind the backdrop doing maintenance. Remember, 4 of these 5 tracks will always have trains sitting on them, so I needed something to protect them from accidents, basically. So this is how I went about that. I started by tracing the area roughly with craft paper. I made it just a little bit bigger than the area that it needed to be. I then cut out a piece of 1/8 inch masonite. I happened to have some scrap left over from another project. Then I built a support frame using 1x2s. I left a slight gap between it and the underside of the sub-roadbed plywood. And then I simply slid the 1/8 inch cutout in place. I'm going to add 1 or 2 removable screws so that it's not a permanent installation. I can always remove it if necessary. Circuitron produces an accessory for their Tortoise switch machines. It's a slip-on connector that eliminates the need to solder any wires directly to the Tortoise machines. I didn't realize when I ordered these that they come in 2 formats. One is disassembled as kits and one is fully assembled. I got the kit version, which means I had to solder everything together, thereby defeating the purpose somewhat. Still, they do make it much easier to do the wiring for the switch machines. If your switch machines are already installed and you're working upside down, they slip on. You can connect the wires to the connectors and then slip them on. So it's all around much easier to do, especially in areas with limited access or difficult to reach areas. I did have a bit of trouble with one of the switch machines. I didn't realize that I was going to use these connectors when I designed the layout, and it turns out that one of them was directly over one of the main girders supporting the layout. The solution was to notch out a small section of the L girder top rail so that the connector could be slipped onto the Tortoise from below. Digging through my box of leftovers, I came across this long spool of 6-conductor telephone wire. I thought that would be perfect for switch machines. The 6-conductor cable makes it easy to wire up groups of 3 closely spaced switch machines very neatly. Each cable of 6 wires is then brought back to a centralized location near where the control panel will be and connected to terminal strips. The top and bottom screws on the terminal strips corresponding to each switch machine will then be connected to the middle terminals of the toggle switches. These are simple DP-DT or 2P-2T toggle switches, which simply reverse the polarity when you throw the switch. And here's a first draft of what the control panel will look like. It's laid out the same way that the control panel was laid out on the existing layout for the staging yards. Before you hang your fascia, it's important to locate the exact position of your control panel, because you'll probably also want to have peepholes on either side of the panel to be able to see the progress and location of trains in the staging yard, as well as the reversing loop, especially when the locomotives pass through the gaps in the rails and the turnouts controlling the loop. I had Home Depot cut me 3 8-foot strips, 18 inches wide, for the fascia. I marked the locations on each of the joists that would be used to support the fascia. I also marked the top of the plywood at those locations, because once you put the fascia up, you can't see where you're drilling into, so you have to measure down exactly where you want the screw to go in. Where necessary, additional joists or extensions were added so that the fascia would butt up against the edge of the benchwork plumb. Installing a fascia by yourself is an interesting exercise in simple physics. You first have to balance the fascia at its midpoint and then carefully install the first few screws. You may be wondering why I didn't start the fascia butt up against the wall. I left an 18-inch gap. The reason for this is that I didn't want the other end of the 8-foot strip to land where I have a peephole to look inside the layout. This would make for a less than secure seam between the two pieces of fascia. Coincidentally, this 18-inch shift allows for the second 8-foot strip to finish exactly the right point at the other end, where there is a sharp transition from a curved fascia to a flat fascia to allow for the electrical panel doors to swing open. Here's a look at the completed installation of the 2 strips of fascia. I will get around to those 2 short sections at either end, and obviously as part of the scenery works, the top edge of the fascia will need to be trimmed. I'll need to find that sweet spot for its height, though, to both maintain the sense that the track is descending through a cut, but at the same time allow the viewer in the aisle to see the train. So that will be an interesting creative challenge. Well, surprise, surprise, I managed to find some time this weekend to actually finish both ends of the fascia. So here are some views of both ends fully installed. These are brand new, straight out of the box. I haven't even changed the decoder addresses yet. I'm just going to let these run without commentary. Enjoy. As always, thank you for watching. If you enjoy layout improvement videos, here are a few others that you may find interesting. If you're not already a subscriber, you can click on the logo on the top right-hand corner of your screen.